Hi Engineering Janta, I am Vaibhav Shukla and today we are going to learn overflow, underflow and peak function in stacks. This is another video in the free DSA series that we are building for you so that you thrive high in your career. Fine. So let's straight away dive in deep and understand what's overflow. So whenever you try and build a stack, think of a stack of clothes. Fine. You put a cloth, then you put another cloth on it, another cloth on it, another cloth on it. You cannot create a tower of clothes. At some point, you have to stop. At some height, you have to stop. Fine. So that can be the value at which you cannot add more clothes to that stack. Now you'll have to move to a new stack. Fine. So what I'm trying to say is, let's consider that you have a stack. Fine, and in this you can store 4 elements. Fine, here you can store 4 elements. So this 4 is the size of stack. This is size of the stack. What is size of the stack? Basically, the number of elements that you can store in a stack are called size of stack. Fine, say 4, 12, 8, 13. These are the elements in the stack right now. Now, if I tell you to do push 22, you try pushing 22 and it can just store 4 elements. Fine. So if you try pushing 22, this will not happen because this stack doesn't have space for that, right? So how to handle this? Before pushing, you generally check a condition, which is overflow condition. So you have a function for it, which is called is full. You have a function called as is full. Fine. So this is basically a Boolean function. This is a Boolean function, and this function will give you either true or false. If this function says false, then add or push can happen. Fine. The insertion can happen. You can add your element. Fine. But if this is full returns true, because this is a Boolean function, it will either return true or false. You can also make an integer function of it, a version of it in an integer format where you get 0 and 1 as the outputs. But generally it is a Boolean function where it returns true and false. In that case, if it returns true, then your stack is full. Push cannot be performed. And in such condition, when no further push can happen, stack is already full, then it is called as overflow condition. Fine. Now this is called as overflow condition. Whenever you have a stack and you're exceeding its size, you're trying to add a new element, you're trying to push a new element when you do not have the space for it. See, here the size of stack was 4, it could accommodate 4 elements. Now you tried inserting another element in it, it cannot happen, it is full till the top level, it is full till the last element. So what will happen? Overflow will happen. Fine. This particular element where I wrote push 22, fine, this cannot happen over it. No? Push 22 cannot happen over it. Fine. So why it cannot happen? Because this stack is full. If it is full, then it is called overflow condition. Fine. Now if you have understood overflow well, you might be aware of what is underflow. But still, I'll explain you. See, when you have this stack, fine, and you had these 4 elements as we discussed, say 13, 4, 12, 11. Now you started popping. You applied first pop, you got 11 as your answer, 11 got removed. Fine. Now top starts pointing out here. Now I do the pop operation again, 12 comes out. When 12 comes out, I remove this 12, fine. Now top is pointing at this particular index. Now I again do pop. What will happen? This will come out. So pop will result into 4. When 4 comes out, top will start pointing to 13. Fine. Now I do the pop again. When I do the pop again, 13 comes out. Fine. When 13 comes out, now the stack is empty. And if I try doing a pop again, just a minute. If I try doing a pop again here, then what will be the issue? Let's check. I try and do the pop again. Can the pop happen? No. Nothing is there in the stack. What will I pop out? Stack is empty, isn't it? So for this, we have a function which is empty. It is like is full only. It is again Boolean function in nature. If it returns false, if it says false, then pop can happen. Fine. If it says false, pop can happen. If it says true, then what does this mean? This means stack is empty. Stack doesn't have an element. If it doesn't have an element, what will you pop out? So for that case, you call it an underflow condition, where pop operation cannot be performed. But in such condition, there is a catch. Top is pointing to -1. Now top is pointing to -1. This location was 0th index, so now it is pointing to -1 index. Why is it pointing to -1 index? We'll understand. Wait. So I'll make you understand this question in the last of this video. So till then, think of it. Why top is -1? Now let's understand what is peak function. So peak is nothing. Say that you have a stack where you have these 3 elements and you have 13, 11, 14. Now top is pointing out here. So what will peak do? When I do peak, peak returns the element at the index pointed by top. Remember this carefully. Remember this line carefully. On whichever index top is pointing, if top is pointing at this index, peak will return the element or the value at that index. For example, this is 0, 1, 2. So top is pointing towards the index 2. So the value that would be returned in peak would be this value, which is 14. Fine. Now remember one thing. Peak is like this. Peak is just like peeking on somebody. Fine. So when you try and peek in a window or in a container, say, what do? You look from the top. What is there, right? So it is looking from the top. And when it looks from the top, it tries and checks what is pointed out by top. For peak function, this top pointer is its eyes. Through this top, it checks which exact element is on the top of the stack and it returns the value of that element which is present on the top. Now let's understand why top equals to -1 when stack is empty. Why is it so? The reason is, in different languages, when you have an empty stack and if top points to 0, then when you do the pop, in this case, when top points to 0, when top is equal to 0, then what will happen? Then some garbage value or a pre-stored value, whatever is stored value is printed. Fine. So this is not your desired output. What you want? When you find underflow condition, you want that even after that, if pop happens, it returns an error to you. Fine. So if your top starts pointing at -1 index, then what will happen? If it starts pointing towards the -1 index, then if you try and do the pop, in this case, when top is equal to -1, in this case, pop will return an error. This will result into an error, because this can be handled as well as top is equal to -1. If you try and pop out in that case, then you will find nothing. Fine. So that is why, this is the reason to avoid this garbage value or any stored value being printed. That is why you use top is equal to -1. Now if you have any doubt in this, you can comment out. If you find this good, you can comment out. The reason for that is, top 3 comments will stand a chance to win PrepInsta Prime subscription for free. So do not miss out on that chance. Also, follow all these social media handles so that you never miss a hiring update. Whatever you've learned, whatever in this video, go ahead, spread this knowledge to your juniors, your seniors, your peers, whoever needs it. Fine. Keep on doing good. Good will come back to you. Thank you. That's all for today. Have a wonderful day.